All right, good afternoon, folks. So this is my second attempt of doing this. Apparently, the first time I did this, I did something to the audio. I don't know what I did. All I know is I sounded like a chipmunk. So here we are again. So I'm gonna do this a little differently since I've already written everything out. And instead of having to rewrite everything, I'm gonna kind of work through and show you the parts to this, and then when I get into solving it, I'm going to cover up what I've already done so you can at least see the equation. That way, if you want to try and work before you see the answers, you'll be able to do that as well. Okay. All right. So first thing is we're talking about the quadratic formula today. And what this is a formula that's going to allow you to solve quadratics no matter what. So in other words, even if you have real or complex solutions, it's going to work. So it's kind of nice. So the first thing you need to know is and understand is we do this based off standard form where we have ax squared plus bx plus c in this particular order, okay? If it's not written in this order where the x squared, the x, and then followed by the constant values at the end, then we need to make sure and rewrite this or at least understand the values go where they go. That way we know how to fill out the formula. Second part that you need to know is the fact that these have to be set equal to 0. And the reason being is because when we solve the quadratic formula, I said that 5 times fast, we're looking for the points of intersection where the graph itself actually intercepts or hits the x-axis. Okay, they're called zeros and roots, but we also call them solutions and x-intercepts. And the reason why we're looking for those points because that's the point in which the y value is equal to 0. So if it's not set equal to 0, then that's one of the first things you're going to have to do. Here's the formula, and it does not change. Memorize it, don't memorize it, but at least know how to substitute it in and get what you want. So the b value, negative b plus or minus the square root of b squared minus 4ac all over 2a. There are plenty of songs about this online, which I'm not going to sing for you, so not going to happen. But anyway, I digress. The other thing you need to know about this is a term called the discriminant value. And the discriminant value is basically the b squared minus 4ac part of the entire equation. If I cover this part up right here, negative b over 2a, that should be familiar to you if you've been working with axes of symmetries. The formula itself, what it does, it takes the axis of symmetry and it adds and subtracts a particular distance from that to get to 2 points. So like if this was your axis of symmetry here, then the distance plus and minus would give you the 2 points that you're looking for there. Okay. So discriminant value tells us what kind and how many solutions we're going to have. Okay. You have essentially 3 options. You either have a positive discriminant where you have 2 real solutions, meaning that your graph's going to intersect that x-axis twice somewhere. We don't know where, but somewhere. Okay. If your discriminant value is 0, that means you're going to have 1 real solution. And that pretty much means that your vertex point of the graph sits on the axis. Okay. It doesn't matter whether it's up or down. Okay. It's going to sit on the axis. So that also means that the answer you get happens to be the vertex point for that graph. And then the last option is you have a negative discriminant, and that means you're going to have 2 complex solutions where we're going to start using the value of I. That also means your graph doesn't actually hit the axis of symmetry here. I'm sorry, not the axis of symmetry, let me rephrase that. The axis here, the x-axis here, there's no intersection points for the actual graph. Okay, that's what that means. All right, so how do you do this? Some of this is already done, so you can kind of see. So I'm going to kind of walk through it. So here's my standard form, again, equal to 0. So when I go through this and I look and I say, okay, do I have the x squared dx and then the constant value sitting, ABC format? In this case, I do. Is this equation set equal to 0? And in this case, it is. So then what I'm going to do essentially is take these numbers, and make them my ABC values automatically. Make sure when you carry the B and the C, if it's a negative or a minus, that you carry it as a negative over here. Okay. So now I'm going to plug in my formula. So negative b, since b is already negative 2, so negative negative 2, plus or minus the square root of b squared minus 4 times a times c, all over 2a. That's how you fill it in. Okay. Once you've done that much, the next thing you want to do is you want to find the discriminant value, which is this highlighted part in yellow right in here. Okay. And we do that, and when we do that, we figure out that the discriminant value in this case is going to be 36. When you plug this in a calculator, by the way, make sure you use these parentheses exactly the way I have it written, because if you don't, it could be that something's going to happen that you don't want to happen. Okay. Especially on this first value right here. Make sure it's parentheses, parentheses, parentheses. I'm not even sure that's a real word, but it is for today. So when I get the discriminant value here, which is 36, that's my discriminant value. Since it's a positive value, that tells me I'm going to have 2 real solutions or 2 real answers when I'm all said and done. Okay. I just realized I forgot my calculator, which, seems to be a common occurrence. And the reason why I need it is because I'm going to show you something, a very common mistake that does happen. So you have the square root of 36, and when you solve it, here's what happens. Square root of 36 is 6. Very common mistake is that people want to essentially go 2 plus 6 divided by 16. Don't do that. That's going to give you an answer that you don't want. Your fraction bar is going to be your best friend. So in this case, what I would do 2 plus 6 in my numerator and divided by 16 in my denominator. I get 1/2 of my first answer. Second one, I do the same thing. 2 minus 6 in my numerator over 16 in my denominator, and I get to negative 1/4. So I got 2 real solutions for my answers. My discriminant said I should have, and that's quadratic formula. Okay. Now, if you've already seen number 2, that's fine. I'm going to put it up here anyway. At this point, if you want to pause and try this first before you do anything else, before I move on, I would pause it. Okay. So again, the first thing I look at is, do I have x squared x and a constant? And is it equal to 0? Well, in this case, no, it's equal to 1. The first thing I got to do is subtract 1 to both sides and make it equal to 0. That way I can get my a, b, and c values. Again, minus minus carry the negatives to your a, b, and c values. Then I set up my equation like this. Negative negative 3 plus or minus the square root of b squared minus 4ac divided by 2a. Then I get my discriminant number, which is that one right there, which happens to be 29. That tells me it's positive. It tells me I'm going to have 2 real solutions. And in this case, because I cannot simplify this 29 down and I'm not using decimals, then my actual answer in simplified radical form would be 3 plus or minus the square root of 29 all over 10. And actually, that would be the final answer I would have on this. Okay. Again, I'm going to show you 3 and 4 next. And again, if you want to pause, and do them before I show you the answers or how I did them, now's the time to do it. Okay. So again, I'm looking at 3 first. It's not equal to 0. So I have to subtract 9 first to get this side. That will give me a negative 6 over here. Okay. I'm going to go ahead and reveal 4 what I'm at it so you can kind of see it. I'll talk about here in a second. I'm going to talk about 3 real fast. So there it is. So negative 6 is equal to 0. There's my A, my B, my C. And again, this first term, because there is no value there, it's an automatic 1. So this becomes a negative 1. There's my setup. Make sure B goes with B right here. Since B is not negative, it's going to become a -4 in a second. For AC, all over 2A. Here I get a negative discriminant of -8. That means I'm going to be having two complex solutions here. The other thing is also I know that the square root of A can be broken down into square root of 4 and square root of 2. Since I'm looking for a simplified radical form, then the square root of 4, which is 2, becomes 2 root 2. So I replace my root 8 with 2 root 2, and since it was a -8, then that I is going to come into play. Okay, -4 here, then we have -2 here in the bottom still. Now, for the most part, if you got to this step right here, I'd be happy. I wouldn't press on it. However, most people would probably tell you to reduce. And to reduce, what you do is you take these three numbers only, and you figure out what number can you divide into all three. In this case, I can divide all three of those by 2. And when I do, this is the answer I get. Now, normally wouldn't have a -1 in the denominator. Normally, I'd switch this to a +2 and so on and so forth. I'm going to show you this. At least you can understand where the numbers go to and where they come from. Okay. The other answer that would probably happen would be 2 plus or minus I root 2. Okay. That's what you would probably see as a final answer. The other thing I'm going to tell you is why didn't I reduce this 2? And essentially it's because it's the square root of a value of 2, meaning that this right here is actually 1.41 and some change. So you can't really divide a square root of 2 by a 2 because it's not an actual 2. Okay. Number 4, and again, I'm going to kind of reveal, I've already revealed it. Again, not equal to 0, so I added 16 first. Then there's my setup. I'm not sure why that's sitting there. That was an accident. There's my equation setup. There's B, 4AC, 2A. I work this part out right here, which is my discriminant value. I get 0. Since I get 0, that means that I only have one real solution to worry about in this case. That means that I'm about to actually find the vertex for this guy. Square root of 0 is 0, which means all I have to work with is -12 over 4, which happens to be -3. Okay, last two, and then again, I'm going to cover the equations, so the workup, you can see them. That way, if you want to pause, oh my God. That way, if you want to pause and work them out before I get to them, go ahead. There are some things I will explain about these in a second. So pause now if you need to. Okay, I'm going to reveal. So number 6. So first of all, notice how this one said equal to 2x. So it means I have to subtract 2x to this side. Here's kind of the thing you need to know. Make sure when you rewrite it that 2x goes in the middle because that becomes your b value for the equation. Okay. Common mistake is people want to move the 2x and then have like x squared minus 6 minus 2x and then get your b, a, b, and c values mixed up. Make sure it's squared x number. Okay. Negative b squared 4ac all over 2a. Okay. Make sure you use parentheses in these guys to find my discriminant. My discriminant value is 28. It means I'm going to have two real solutions when I'm all said and done. 28 does break down into 4 and 7. So root 4 and root 7. 4 is a perfect square. So square root of 4 is just 2. So 28 will break down into 2 root 7. Again, 2 plus or minus 2 root 7 over 2. 2, 2, and 2. I can divide all those by 2 to get 1, 1, 1. And again, I don't necessarily need this one here. So a clean solution would look more like this. Okay, but if you wrote it like this, it wouldn't necessarily be wrong. This is just clean. And then the last one. And again, not equal to 0. So one of the questions that could be asked or might be asked is, do you move the negative 3x squared to this side, or do you move this 3x plus 7 to this side? And the answer is it doesn't really matter because you're going to get the same answers. So what happens is if you kept it as a negative, you would have a curve that is vertically upside down, which becomes a maximum. If you made and moved it to this direction and made it a positive 3x, that means your curve would open downwards this way like this, I'm sorry, open upwards like this. My bad. And the reason why it doesn't matter is because the x-intercept or the solutions, regardless of the direction it opens, would be the same. So, that's really a choice. These are negatives because why not? It's math. Most people would be inclined to use positives. Whatever. This can only make you stronger in working with negative values. So there comes my A, B, and C values are all negative, and that's okay. Negative B, square root of B squared minus 4AC, all over 2 times A. I'll work it through. It's square root of a negative 75. That means it's going to have 2 complex. That means I'm going to have I in my answer. 75 also breaks down into 25 and 3. Square root of 25 is 5. Square root of 3. So my answer would be 3 plus or minus 5I root 3. The I, because this was a negative to begin with, all over negative 6. Now, this would be an acceptable answer. A clean answer or a reduced answer might be that they reduce the 3 over negative 6 to negative 1/2 and then keep this part together. That's the phone. Let me go get it. It's real fast. Anyway, so this would be a clean answer. This would be an acceptable answer. Okay. There are situations when you would see this, and I can't tell you when because it just really depends on who you're working with. So this is clean. This is acceptable. So, but anyway, there's a quadratic formula for you. And again, the main thing is, can you plug it into the formula? Can you determine the discriminant value and actually know what the discriminant value means? And finally, in the end, can you actually solve it to the final solutions, depending on what they are? Okay. Anyway, that's all there is. Yeah, y'all have a good afternoon, and peace out.